Alright, this is Algebra 2, Week 3, Exponentials. Worksheets, answers 9 through, 17 or 18. The Fahrenheit temperature, we're on number 9. The Fahrenheit temperature, f of t, of a heated object at time t in minutes can be modeled by that function below. F sub s is the surrounding temperature, F sub 0 is the initial temperature, and K is the constant. Coffee at a temperature of 195 degrees Fahrenheit is poured into a container. The room temperature is kept at a constant 68 degrees Fahrenheit and K equals 0.05. Coffee is safe to drink when the temperature is at most 120. To the nearest minute, how long will it take until the coffee is safe to drink? Alright, so we got to plug some things in. The initial temperature of the coffee was 195. The surrounding is 68. The ending temperature that we want so that we can drink it is 120. So f of t is equal to 120. That's the final temp we want. The surrounding temperature is 68. The initial temperature of the coffee was 195 minus the surrounding temperature of 68. E to the negative k, which is, we know k. The constant it said was 0.05, so negative 0.05 times t. Alright, so multiple choice test strategy was to take each one of those answer choices, plug them in for t, and then just type in the right side of the equation and see which one comes out to be 120. However, if it were a show all your work problem, you still need to know how to do that. So I see that I have an exponent in the air. That tells me that my variable exponent, I'm going to need logs to solve this, but I am not ready to take logs until I get that e to the negative 0.05t by itself. So the first thing I'm going to do is subtract the 68. And that's going to give me, I think, 52. Okay. And then 195 minus 68 is going to give me 127 e to the negative 0.05t. My e is not yet isolated, so I need to divide both sides by 127. So 52 divided by 127 is 0.40944888189. And that's still equal to e to the negative 0.05t. So now I need to log both sides. Because we have an e, we're going to natural log both sides. And I'm going to be lazy and not write that down. So I'm going to take the log of that yucky decimal. And remember, the reason we're taking the logs is to get that exponent out of the air. So negative 0.05t comes down, log e. Now, hopefully you remember that the log of e has a value of 1. So ln e, and ln automatically has a little base of e. So this is asking the question, what exponent do I put on this base of e to get e for an answer? Well, e to the first is e. So the ln of e has a value of 1. And if you divide by 1, nothing happens. So we're going to divide by 0.05t. Now the fact that I put this little 1 up here is useful when you do the regents, because that tells your graders that you understand that that has a value of 1 and that you don't just drop it off the face of the earth. So I apologize. I'm dividing by negative 0.05. So now I got to type in the natural log of that nasty long decimal. So ln of that yucky decimal divided by, end parenthesis, don't forget the end parenthesis, that's huge, negative 0.05, and I forgot my divide sign. Hang on a sec. Alright, so I'm ending up with t equaling 17.85, so to the nearest minute that would make it 18. Alright, number 10. A study of black bears in the Adirondacks reveals that their population can be represented by that function. T is the number of years since the study began, which function is correctly rewritten to reveal the monthly growth rate of the black bear population. All right, so we need to edit our function so that it's in terms of months instead of years. All right, so normally we have this for our exponential growth formula. And if we are going to change the time and do anything other than years, we need to adjust the rate and we need to adjust the time. So that means the rate has to get divided by 12 so that you're taking your yearly rate and splitting it up into 12 equal parts. And then t, if it's in years, says do it once a year. Well, now we're going to change it to months, and there happens to be 12 months in a year, which means I have to do it 12 times a year. So we need to take their original equation and make those changes. So P of t equals 3,500. I'm going to separate the 1 and call it 1 plus. That means my rate was 2.5%, so I get the 0.025 divided by 12 raised to the 12t. Now the first two choices are the ones that are raised to the 12t, so it's got to be one of those two. But now we just got to figure out what what's inside the parentheses is equivalent to. So 1 plus 0.025 divided by 12 gives me 1.002, and so we're going to pick number 1. Okay. If you want a backdoor approach to check your work on this question, t is the number of years. So pick a number of years. All right. So I usually stick with my favorite number 3. So if I plug in 3 years, I want to see what that equals. So 3,500, 1.025 raised to the third. I'm getting 3,769 and some change. So now I know that I'm going to plug the 3 because t still stands for years. So I'm going to take each one of my answer choices and plug in a 3 and see which one gives me the 3,769, and that would be choice number 1 as well. 11. A population of 950 bacteria grows continuously at a rate of 4.75% per day. Write an exponential function that represents the bacterial population after t days and explain the reason for your choice of base. All right, well, continuously is PERT. PERT is a brand of shampoo, so I think of continuously washing my hair. All right, so, A equals P e to the RT. The population of 950 bacteria. P is the principal, the beginning amount. E, the rate is 4.75, so change it to a decimal by moving it 2. And write a function n of t. So I can't call it a, I have to call it n of t. Reason for the choice of base. Compounding continuously requires an E. Determine the bacteria population after 36 hours to the nearest bacterium. T is in days because they told me it's rate per day. So I need to figure out what 36 hours is. Well, 36 hours divided by 24 hours gives me 1.5 days. So I'm going to plug in a 1.5 for the t. So 950 e to 0.0475 times 1.5. Remember, anytime you have an exponent that is more than one item, it has to be in parentheses in your calculator. So 950 and e caret parentheses 0.0475 times 1.5 end parentheses, enter, and I'm getting 1,020 to the nearest whole number. Number 12, What's that expression equivalent to? They give us a radical, and all the answers are in terms of fractional exponents. So I know that radicals are fractional exponents. A fourth root is raised to the fourth power. So each item inside that radical is going to be raised to the 1/4 power. So I have 81 to the 1/4 power. I have x to the 8th to the 1/4 power. And I have y to the 6th to the 1/4 power. Alright, so they want 81 to the 4th power, which you could actually type into your calculator, but it's saying what times itself 4 times equals 81. That would be a 3, so choice 3 and 4 are out. When you have a power to a power, you multiply. 8 times a 4th is 2, so automatically that tells me I've got to have choice number 1. 6 times 1/4 is going to be 3/2, which verifies that it is choice number 1. 13. Chet has $1,200 invested in a bank account modeled by that function. P of n is the value of his account after n months. His debt is modeled by that function, where Qn is the value of the debt after n months. After n months, which function represents his net worth? Alright, so net worth is how much money you actually have. So what you have is when you take all your income and you subtract your expenses. So in this case, it's what he's got in his bank minus the debt he has to pay off first, and that says that's what he's actually worth after he pays his debts, what they're talking about net worth. So we have to take the P of n function and subtract the Q of n function to get his net worth, and that happens to be number 3. Number 14, Susan won $2,000, invested it into an account with an annual interest rate of 3.2%. If her investments were compounded monthly, which expression best represents the value of her investments after t years? Alright, so this is exponential growth. Our basic exponential growth formula is y equals a 1 plus r to the t. This is for a yearly compounding. If we're going to do it monthly, we have to make 2 edits. We have to change the rate from a yearly rate to a monthly rate. And to do that, we're going to divide it by 12. Take the yearly rate, divide it into 12 pieces. And then t is time. We don't want to just do that once a year. We need to compound our interest 12 times in a year because there's 12 months. So now we're going to fill everything in. The initial amount is 2,000. 1 plus the rate changed to decimals, 0.032, divided by 12 to the 12t. And I don't see that anywhere, but I'm guessing it's number 1 because it's the only one with the 12t. But what we're going to do is figure out what actually goes in parentheses. 1 plus 0.032 divided by 12. And yep, I get 1.003 inside the parentheses. So the choice is number 1. Number 15 says p is greater than 0, and that's just to let you know so you don't get any imaginary numbers from the radicals. Does not change how you do the problem. And they are asking, is this expression where we're multiplying this stuff together equivalent to that? Justify your answer means you need to show work. Alright, well, a couple ways to do it. We could simplify what's on the left and compare it to what's on the right, and since there's really nothing to do on the right expression, I would say that's already plane of attack. So I see parentheses being raised to the 8th power. I know a power to a power multiplies, so I'm going to multiply that 8 to both of those exponents. 2 times 8 makes p to the 16th. A half times 8 makes n to the 4th. And then I'm also going to change this radical to having regular exponents so that I can actually combine these terms together. So I know that a square root is a power of a half. So I'm going to take that half and multiply it to both of those exponents. So that becomes p to the 5 halves. 4 times a half is 2. All right, so now I can actually multiply these together. And when we multiply like bases, we add their exponents. So 16 plus 2.5 makes p to the 18.5. And then 4 plus 2 is 6. So if I want to change this, that gives me p to the 18th. And the leftover half means that I'm going to have a p under a square root. And then I have an n to the 6th. There's my justification. Number 16 is asking us to write an exponential regression equation. So go to Stat Edit and put the x values into L1 and the y values into L2. Then you're going to go Stat, Calc, and exponential regression is number 0. So we're going to do Stat, Calc, number 0. That shows our work. And it says round the values to the nearest thousandth. 1,000 has 3 zeros, so we want 3 decimal places. So 101.52, that'll round up to a 3, times 0.88, that'll also round up to a 3, to the x. Use this equation to algebraically determine the altitude, which is an x value, to the nearest hundredth when the air pressure is 29. 29 air pressure, that's a y value, so we're plugging that into y, and that tells me this would have been a 4-point question on the Regents exam, because we are now solving for x. Since x is a variable, that's an exponent, that means we're going to need logs. That means it's a 4-point question. Before we use logs, we have to isolate the 0.883 to the x, so I'm going to divide both sides by 101.523. And that gives me 0.28564955572 equals 0.883 to the x. Now that the exponent term is isolated, we're going to log both sides. Okay, so I'm going to get lazy. I'm going to draw an arrow saying I need to take a log of that long number. And the point of taking a log is to get that x down in front. And now to get x alone, I'm just going to divide by the log of 0.883. Alright, so we got to take the log of that big number, end your parenthesis, divided by log 0.883. Don't forget the word log, it'll make all the difference if you do. And I'm getting 10.07 when I round it to the nearest hundredth. 100 has 2 zeros, 2 decimal places. 17. A certain pain reliever is taken in 220 milligram dosages and has a half-life of 12 hours. That's the function that can be used to model the equation. A is the amount of pain reliever remaining in the body after T hours. According to this function, which statement is true? Every hour, the amount of pain reliever remaining gets cut in half. That would be false. It says it has a half-life of 12 hours. That means every 12 hours it gets cut in half. So it's not number 1. In 12 hours, there's no pain reliever remaining. Again, not true. Every 12 hours it gets cut in half. In 24 hours, there's no pain reliever remaining in the body. Well, if you have an exponential function, then theoretically, you always have medicine in the body, because you can never get to 0 with an exponential function. You can get infinitesimally small, to which we say there's nothing left. So let's look at the next one. In 12 hours, 110 milligrams of the pain reliever is remaining. Well, we know that every 12 hours, the amount of medicine gets cut in half. The amount of medicine that they start with is 220. So after 12 hours, it gets cut in half, which would give you 110 left. So number 4 is actually the accurate description. Okay, number 18. For a given time x in seconds, an electric current y can be represented by that equation. which equation is not equivalent. These look really rough, and what this is doing is playing around with your knowledge of exponents. It's a little bit beyond the scope of an Algebra 2 class. This is more of a pre-calculus type of thing, which the Regents is allowed to throw at you. So I'm going to go to telling you that if they give you an equation and ask you which one is equivalent, the easy way to check is to type them into y equals and compare tables. The only issue is you have to be very careful when you type it into y equals. So y1 is equal to 2.5 parenthesis 1 minus 2.7 caret, there's more than one item in that exponent, you have to put the exponent in parentheses. So negative 0.10x, end the parenthesis for the exponent, and then end the parenthesis that was already in the equation. That's how you're going to type in y1. All right, pick the answer you think it is. And by quickly looking, I'm not exactly sure. So I'm going to just start with number 1. So I'm going to type into y2, 2.5 minus 2.5, parenthesis to go with theirs, 2.7 caret, now open a parenthesis for the exponent, negative 0.10x, end the parenthesis for the exponent, now end the parenthesis that they originally had. All right, so I have to go type this in too. 2.5 parenthesis 1 minus 2.7 caret parenthesis 0.10 x end parenthesis for the exponent, end parenthesis for the expression. y2, 2.5 minus 2.5 parenthesis 2.7 caret parenthesis negative 0.10 x end parenthesis for the exponent, end parenthesis for the expression. Go check out the tables. And they are not at all the same. So it is not number 1. Wait a minute. I'm thinking I typed something wrong. Yep, I did. I forgot my negative on the first equation. Give me just a moment. Aha. All right, so when I type it in correctly, number 1 actually does match. Okay, so what they really did here, it had nothing to do with exponents at all. They took the 2.5 and distributed it into the parenthesis. Since the parenthesis itself doesn't have an exponent, they can do that. So 2.5 times 1 is 2.5. And then you cannot multiply the 2.5 to the 2.7 because the 2.7 has an exponent on it. So they just showed you that they were going to multiply the 2.5 by the expression 2.7 to the negative 10x. So all that was really was a simple distribute problem with some really yucky looking numbers. Okay. 19, and we'll end it here. If n is equal to the square root of a to the 5th, and m is equal to a, what do you get for n divided by m? So we are supposed to divide the stuff that n is. So the square root of a to the 5th, we're supposed to divide by a. So what I did is I plugged in the n in the numerator, I plugged in the m in the denominator. So we need to simplify that. Stuff under radicals do not mix with stuff outside of radicals, so I'm going to change this to having a fractional exponent because then I can subtract the exponents. So I know a radical is a 1/2 exponent, which gets multiplied to the 5. So this is a to the 5/2 divided by a. So if I subtract the exponents here because I'm dividing, that gives me a to the 3/2, which I'm not seeing as a choice. So it's not 1 and 2. Now what I'm going to do is rewrite that in radical form to see if I get one of the other choices. So this is a cubed, and the 2 in the denominator makes a square root. All right, the other one will be in part 3.